Hello everyone. Okay, today we will learn about the empirical rule or the three rule stigma, the 68, 95, 99.7. Its history, definition, formula, limitations, and applications. Empirical rule. The 68, 95, 99.7 was first coined and discovered by Abraham de Moivre in 1733 through his experimentation of flipping 100 coins. The term empirical means based on, concerned with, or verifiable by observation or experience rather than theory or pure logic, which means that the empirical rule was based on experimentation and is being used to estimate certain data points or probability. So, what is the formula used in empirical rule? I suggest to remember this formula, ultimo. Okay, so ultimo. The micro, a Greek symbol of micro means the average or the mean. And the standard deviation is the sigma. And then M will be the multiplier. One, if you want to get the range of data of 68% of data. Two, if you want to get 95% of data. And then three, to get the 99.7% of data. Okay, for the next slide. So this I will discuss the what is the empirical rule. So empirical rule says that in the one standard deviation, plus minus standard deviation from the mean would cover 68% of data set of your data. Then if we try to get the two standard deviation from the mean, we are going to get the 95% of the data. And then the three standard deviation from the mean will provide us 99.7 of the data. So that is why 68, 95, and 99.7. What are the limitations of empirical rule? Empirical rule is only applicable for distribution that are symmetric and unimodal. So in this case, this is a symmetric, but it has two modes. It has two peaks, so this one and this one. So that's why empirical rule cannot be used in here. What about this one? It is unimodal. Fortunately, it is not symmetrical. It is positively skewed. Therefore, empirical rule is not also applicable for this graph. So when do we use empirical rule? Okay, first, it is used to identify if a data set or feature is a normal statistical distribution. Like I said, if it falls under 68, 95, 99.7, it is automatically presumed that it is a normal statistical distribution data. It also provides a quick estimate of the spread of data in a presumed normal statistical distribution. For example, if we have a data about height in a certain age, uh, it is presumed to have a normal statistical distribution. We can estimate the spreadness of the data through empirical rule. For the third one, we can have a quick assumption of the most probable input of the new data. So to explain further, this is a example from our number one application. Identify if a data set is a normal distribution. The given is the housefly wing length. There's a 100 entries and in millimeter times 10 negative 1. So using the formula, again, using the formula, we try to get the m equals 1. We got the 68% from the lower limit of 41.58 and upper limit of 49.42. So if m equals 2, unfortunately, we get the 96%, which is still close from 95, from the lower limit of 37.6 and upper limit of 53.34. And if the m equals 3, the multiplier is 3, we get 100% of the data. So if we try to get the MX Excel, I inputted this portion, all the data in here. Then we try to get the mean. Getting the mean is just getting the average. While for standard deviation, we use this formula, stdev.s, because it's a sample size. Then this is subtracting the mean to the first standard deviation. So we get the lower limit and then the upper limit. So we try to get if this data is within this limit, so no. And then we get the 68. So out of 100, 68% are within those limits. While for the second standard deviation, we got 96%. And lastly, for the third, we got 100%. So what does it tell us? Uh, we have identified that it is somewhat normal distribution set. There might be an error, but it's very minimal. So instead of going through that processes in Excel, we have another two application of uh, this empirical rule. It's quick estimate of the spread of data in a presumed normal statistical distribution. We already used the 68, 95, and 99.7 and get the lower and upper limit, which is uh, almost the same with the previous slide. Let me show the previous slide. See, this is the actual, while this is the estimate. So almost the same. That's why it's a quick estimate of the spread of data in a presumed normal statistical distribution. We have presumed that the data set is already normal, so we don't need to scrutinize all the data set in here. We just, as long as we are given the mean and the standard deviation, we can easily estimate the range of the data. So this means that 68% would fall under 41 to 58, 41.58 to 49.42, and 95% of the data would fall under 37.6 to 53.34, and 99.7% would fall from 33.74 to 57.26. Okay, so you can use both if you want to get the exact spread of the data. Use number one just to be sure that the data is a normal distribution. While number two, we try to get the estimate. If we are already confident that the data set is a normal statistical distribution, then we can use this estimate. I forgot to show you that the graph for this one, I already plotted the histogram. It is symmetrical, but there are differences between the endpoints of our histogram. So the errors might come from there. So that's why it's called estimate. Because we still expect errors, but in this case, it's very minimal. So what's the third one? The third is quick assumption of the most probable input of new data. We are given already the data set and the mean and the standard deviation. So what if there's another data that will be coming from another source? So it is presumed that there's a 60% chance that the new data is within 41 to 50, 41.58 to 49.42. And there's a 95% chance that the data will be coming from 37.66 to 53.34. And there's a 99.7% chance that the new data will be between 33.74 to 27.26. Okay, so why? Let us go back. Okay, the histogram actually also shows the probability of the data and the values. So the higher the peak, means that it is most probable that the data will be coming from here. So using empirical rule, we can use this as our uh, percent of chance identifier, or the probability that the next data will be between here. Okay, so to summarize, empirical rule is also known as the 6895 or 99.7. And empirical rule is only applicable to symmetric and unimodal, which is a normal distribution. And it was discovered and coined by Abraham de Moivre in 1733. And the formula, of course, don't forget, ultimo. Okay? So that's it for today. I hope you learned something about this discussion. And hit the like button and subscribe. Thank you very much.